Good morning to all. Myself Dr. K. Manoharan, Associate Professor, Department of Biomedical Engineering. So today class we are going to see about 8237 interface DMA controller. We can say it's an 8237 or 8257, both are the DMA controllers. So it is a device, it will be used to transfer data directly from an IO to memory without help of CPUs. So it performs high-speed data transfer between a memory and IOs without interfering CPUs. So same time CPU can perform some other task, so it saves the CPU time. Look at the block diagrams. So it have 4 channels. Look at this. This is a channel 0, channel 1, channel 2 and channel 3. So this is an actual data bus buffer. This is an interconnects this internal bus with an microprocessor through these buffers. So this is a bidirectional data bus buffer to connect the data transfers. Look at this. This is the read-write control logic. So here IO read, IO write. So these control signals will be both input and output. So why it's like this means actually for this device we need to have this IO read, IO write as an input signal. So it needs to generate the IO read, IO write control signals to interfere the data transfer between IO and memories. So it generates the signal also and sometimes it gets the signal also. That's why it's a bidirectionals. Look at this, this is the reset signal and this is A0, A1, A2, A3. So this also bidirectional because actual address bus will be comes from microprocessor to this DMA controller. After that, once it take care of this address bus, so it need to generate that addresses. So for both IO device and then memory, it need to generate the address. That's why this address bus also bidirectional here. Look at this. This is the control logic and mode set register. So remaining address bus like an A4, A5, A6, A7 here. This is the output signals and then ready signal. This is HRQ. That is a hold request and this is the HLDA hold acknowledgement. This is a memory read and memory write. So this also generated output signals and then address slash enable address strobe TC terminal count mark. So because actually the data transfer will be taken care of this DMA controller. So for data transfer, so we need to select that particular IO devices and then memory address also. Again, we need to generate the required control signals like whether the IO device is a read signal or a write signal. That is a read operation or write operation. Similarly, for after that getting the data, whether it should be stored in memory or the data should be read from that memory. That is, if an IO device is an input device, we need to read the IO device and store the memory. If it's an IO device is an output device, we need to get the data from the memory and send to the IO devices. So all these possible operations should be taken care of this DMA controller. So for that, the required control signals must be generated through the DMA controllers. Look at this. This is a priority resolvers. So sometimes if we have a multiple requesters, so it decides which priority, that is which DMA request will be considered first. So this decides. Look at this. We have a 4 channels. So each channel will be a 16-bit registers. This is a channel 0 and this is channel 1, channel 2 and channel 3. So each channel have different DMA request and DMA acknowledgements. So channel 0 it's a DMA request and DMA acknowledgement 0. If it is a channel 1, DMA request 1 and DMA acknowledgement 1. Similarly channel 2 it's a DMA request 2 and DMA acknowledgement 2. Channel 3 is a DMA request 3 and DMA acknowledgement. So whenever IO device needs to transfer data from the device to memory, it gives a request to the DMA controller through this DMA request. Once this DMA request is received, so it considers this request and then it gives an DMA request. So this is the look at this hold request HRQ. So this is a DMA request. So this will be given for a microprocessor. So once the microprocessor gives an acknowledgement, that will be received by this HLDA hold acknowledgement. That means the microprocessor can free the address bus and data bus. Further, the DMA controller can use the same address bus, data bus to transfer the data. So after receiving this hold acknowledgement signal, so the DMA controller gives this DMA acknowledgement device to that particular IO device. Once it gives this acknowledgement, it can start the data transfer from that IO device to memory in high speed. So till it completion, so the address bus, data bus will be under control of DMA controllers. So if you have a multiple requests, all the requests will be completed one by one. So simultaneously data transfer cannot be possible. Only at a time one channel will be used because we have only one set of address bus and data buses. So we have this data bus buffer, read-write control logic, again priority resolvers and DMA channels. Look at this, this is the actual configuration. This is the DMA controller and this is the peripheral device and this is the microprocessor and this is the memory. Look at this, how it happens. So actually this is the DMA controller. So whenever the peripheral have an data to be transferred, so it gives the request. Look at this, this is the DMA request will be given to DMA controller. Once DMA controller receives that request, it gives that HRQ, that is a hold request. So once this hold request reaches the microprocessor, if it is able to free the address bus and data bus, it gives an acknowledgement. This is, look at this hold acknowledgement. So this hold acknowledgement will be given to the DMA controller. So once it receives this, DMA controller gives the DMA acknowledgement to the peripheral device. Once it gives like that, so look at this, this is an address bus and this is the data bus. It comes under the control of DMA controller. So look at this, these switches will be controlled. This is control bus, data bus, address bus. So this switch position comes to this. So here this position and this position and this position. What happens? So further the control signals, data bus and address bus all will be in the under control of DMA controller. So DMA controller decides which operation, whether IO read or IO write or memory read or memory write, and then which address to be readed or which address to be written. Similarly, which IO address. So everything will be decided by the DMA controller. So all this microprocessor will be disconnected. Now this address bus, data bus and control bus will be under control of DMA controller. It can generate the required control signals and transfer the data from this peripheral device to memory continuously by using this address bus and data bus. After completing only, it free up this address bus and data buses. Thank you.